All right, our sixth and final objective for Chapter 5 talks about inequalities in triangles. Everything we've talked about so far has been doing with sides and special segments in triangles. Today we're going to talk about how the angles are related to the sides in triangles. So we got corollary to the triangle exterior angle theorem here that we're going to talk about, looking at this statement. The measure of an exterior angle of a triangle is greater than the measure of each of its remote interiors. So remember that an exterior angle is simply an angle that occurs on the outside of a triangle by extending one of the sides, shown here as example, or as angle 1. What this is saying is that angle 1, since it's on the exterior, has to be bigger than angle 3, and angle 1 has to be bigger than angle 2. That's what this statement over here says. In symbols, it looks like this. The measure of angle 1 has got to be greater than the measure of angle 2, and the measure of angle 1 has to be greater than the measure of angle 3. Okay? Now, if we take a look at problem number 1 to the figure at the right, we're asked to figure out why the measure of angle 2 is greater than the measure of angle 3. All right, so looking at what we've got up here, taking a look at this statement, why is the measure of angle 2 greater than the measure of angle 3? Well, let's start by recognizing that BDC is an isosceles triangle. So if BDC is an isosceles triangle, that means the base angles of that triangle have to be congruent. So we can state right off the bat, without doing any work, that angle 1 and angle 2 have to be the same size. And why is that important? Well, if we know that these two angles are the same size, then we can relate angle 1 to triangle ABD. Angle 1 is an exterior angle of triangle ABD. So by the inequality theorem that we just talked about, angle 1 has to be greater than angle 3. And since angle 1 and angle 2 are congruent to each other, then angle 2 must also be greater than angle 3. Okay? So how are we going to put that down into words? Well, we're going to say this, that angle 1 and angle 2 are congruent to each other because there's an isosceles triangle theorem. Okay? And since angle 1 is greater than angle 3, then angle 2 must be greater than angle 3 as well. Okay, if you're looking for a property to explain that, that would be the transitive property. Hey, I'm going to go through got one with you. Why is the measure of angle 5 greater than the measure of angle C? And I want you to see this as well. Now, I mentioned earlier that there are multiple triangles at work here. Here's one. Got one in red, and now I'm showing you one in green. That makes angle 5 an exterior angle to triangle ADC. If angle 5 is exterior to triangle ADC, it must be larger than the remote interiors. The two remote interiors are 3 and C, so angle 5 has to be greater than angle C because it is an exterior angle of triangle ADC, and angle C is a remote interior angle. Okay, theorem 510, we're going to look at how the angles are related to the sides in one triangle. And if we take a look at this theorem, we have the statement that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So what that is saying is, if you know that XZ here is larger than XY, which is shown here, so this side is obviously longer than this side, then the measure of angle Y, since it's opposite the longer side, has to be larger than the measure of angle Z. That's shown here, since angle Z is opposite the shorter side. And we're looking at kind of a real-world example here in problem 2 that illustrates this theorem. Okay, so we have a triangular park in town, and a landscape architect wants to place a bench at the corner with the largest angle. Okay, which two streets form the corner with the largest angle? Okay, well, the sides here are already marked for us. We have 175, 120, and 105. So the angle opposite the longest side will be the largest angle. So here's our longest side, and the angle opposite that side is right down here. So the two streets that form the corner are Valley and Martin Luther King Boulevard. Now you can take a look at Got It question 2, and again, you can bring those questions to class or bring answers to class if you want to get those checked out. Okay, Theorem 511 says essentially the same thing as Theorem 510, but in Theorem 510 we knew about the sides but didn't know about the angles. In Theorem 511 we know about the angles but don't necessarily know about the sides. So if we take a look at what we are shown here, what the theorem says, if two angles of a triangle are not congruent, and the longer side lies opposite the larger angle. So here we're told that the measure of angle A and the measure of angle B are not equal to each other. In fact, the measure of angle A is larger. So if that's the case, then the larger angle indicates the larger side. So BC has to be bigger than AC because of the relationship between those opposite angles. Okay? Now if we take a look at problem 3, we're asked to list out the sides in order from shortest to longest. So that's going to require us to figure out the measure of angle T. Okay? Now we can add up the two angles we've got. We've got 58 and 62. And if we add 58 and 62, we're going to get 120. So we have 120 degrees used up between angle U and angle V. Sorry about that. Okay, and that leaves us 60 degrees left to use on angle T. Okay. Now the importance of the angles is indicates the length of the different sides. So 58 is our smallest angle, so TV would be the shortest side. So from shortest to longest, TV comes first. Okay. The next largest angle, the next angle going up, is 60 degrees. So the side opposite that 60 is UV. So UV is the next one in line. And that leaves us with UT as the longest side. And that makes sense because the longest side is opposite the largest angle. Okay, so that relates the angles to their sides. Now let's take a look at the triangle inequality theorem. This relates the sides to each other. Okay, in the triangle inequality theorem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. What does that mean? Well, below, we can see what that means in symbols. Okay, so xy plus yz, xy here, yz here, has to be larger than xz. Same thing goes for the other two sides. Yz plus xz, yz plus xz has to be greater than xy. And finally, xz plus xy has to be greater than yz. Okay, now in problem 4, we're going to relate that information to decide whether or not this can be the sides of a triangle. So if you look at problem 4, we've got 3, 7, and 8 for our side lengths. According to this formula, or according to this theorem, I mean, xy, yz, two sides have to be larger than the third side. So let's see if that holds for this information. 3 plus 7 is greater than 8. Okay, so this one checks out. We're going to do the same thing with the other sides. 7 plus 8 is greater than 3. So that one checks out. And finally, we took 3 plus 7, we took 7 plus 8. Now we're going to take 3 plus 8 and see if that is greater than 7. If that checks out, then the answer is yes, that can be a triangle. Now let's take a look at part B. If we add up the first two, 5 plus 10, is 5 plus 10 greater than 15? The answer to that is no. It is equal, but it is not greater than. This has to be greater than, not greater than or equal to. It's got to be greater than. So this is no. That cannot be a triangle. Okay, Got It question 4 takes you through some of the same information. If you have questions or you want to try that on your own, please do so. Bring any questions or answers you have to class to get. Okay, the next thing we're going to look at is called the hinge theorem. And the hinge theorem relates inequalities in two different triangles rather than inequalities in the same triangle. Okay, so the theorem in word form looks like this. Okay, if two sides of one triangle are congruent to two sides of another, and the included angles are not congruent, then the longer third side is opposite the larger included angle. What exactly does that mean? If two sides of one triangle are congruent to two sides of another. Let's take a look at that part first. Okay, so here's one pair of congruent sides. Here's a second pair of congruent sides. As long as you have that, and the included angles are not congruent. So included angle meaning the angle in between those sides, here and here. If they're not congruent, then the longer third side is opposite the larger included angle. Okay, so here angle A is larger than angle x. That's told here. If measure of angle A is greater than the measure of angle x, then we can say this. Okay, that BC, since it's opposite the larger angle, must be greater than YZ because it's opposite the smaller angle. Okay, so let's go ahead and take a look at problem number 1 that uses this theorem. Okay, we've got an exact replica of the hinge theorem that's shown up above. We have two pairs of congruent sides which are necessary. There's one pair, here's two pairs of congruent sides. Okay. Now the included angle here, this is a 90-degree included angle, and this is a 70-degree included angle. When those angles are not congruent, then the opposite side the opposite side, the larger side, is opposite the larger angle. So this side, SK, has to be greater than YU because 90 is larger than 70. Now, which one of these options indicates that? Looks like option B. So option B would be your choice there. SK is larger than YU. Okay. Let's take a look at Got It question 1, part A. Right, what inequality relates ln and OQ? Well, we have congruent sides here, this time not with markings, but with the lengths that are given there. We've got congruent sides. We've got non-equal angles, angles that are not equal to each other. 125 is larger than 78, so ln must be greater than OQ because ln is opposite the larger of the two angles. Okay, now that's the hinge theorem. Okay, there are more applications of the hinge theorem, starting with problem number 2. Okay, in this diagram, we have a carnival swing ride. Okay, and as the speed of the swing ride increases, the angle between the chain and AB increases. Well, this chain is indicated here. Okay, here's your chain, here's your chain. What it's saying is as the ride gets faster and faster, this angle here increases as the ride speeds up. Okay, so the question is the rider farther from point A at time 1 or time 2? Well, here's point A. So what we want to know is as this ride speeds up, does the distance from A to C increase or decrease? So which one's going to have the longer segment? Okay, so angle 1 here at time 1 is smaller than angle 2 at time 2 because the ride is increased. So where is the distance greater? At time 2. Okay. Okay, taking a look at Theorem 514, this will end your new material for Chapter 5. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the included angle is opposite the longer third side. Okay? So, in picture form, here's what it's saying. If you have two congruent pairs of sides, which is what we've been working with the hinge theorem all throughout this portion of the notes, okay, and the third sides are not congruent, which these sides are not, so BC is greater than YZ, then the measure of angle A has to be bigger than the measure of angle X. Now that's to be expected from the hinge theorem. Okay, so that's stated right over here. Well, I'll just go ahead and write it in, I guess. Angle A is greater than angle X. Okay, so what are the possible ranges? We're taking a look at example 3 here. What is the range of possible values for X in the figure at the right? So here's the converse of the hinge theorem. We have two pairs of congruent sides. Okay. We have a pair of sides that is not congruent. So angle K is going to be less than angle N. Okay, because angle K is opposite of 7, angle N is opposite of 9. Now it's another range of values question, so we're going to be working with inequalities. Here's what you need to know. This angle K has to be less than 90. So we'll go ahead and start there. 3x plus 18 has to be less than 90. We go through algebraically here. 3x I mean, has to be less than 72. We subtract 18 from both sides. So x has to be less than 24. Okay? we're looking for a range of values. We're not just going to say x is less than 24, because that would mean anything in the negatives could work, and we don't necessarily know if that can work. But angle measures have to have some value. So not only does angle K have to be less than angle N, angle K also has to be greater than 0. So we'll say that 3x plus 18 has to be greater than 0. Okay, if we subtract 18 from both sides on that case, we get 3x is greater than negative 18. Divide both sides by 3, and x is greater than negative 6. Okay, so our possible range of values. Here's our low end, here's our high end. In inequality form, that'll look like this. X is less than, negative 6 is less than x, which is less than 24. So negative 6 to 24 is our possible range of values. Okay, that concludes your notes for chapter 5. Again, if you have any questions, please bring those to class and we will address them there.